Welcome back to Lessons for Math 151 Statistics. In this lesson we're going to be looking at the binomial distribution. This lesson will proceed in three parts. The first part we'll be learning what Bernoulli trials are and some basic calculations. In the second we'll get beyond the basic calculations and also learn how to use our calculator to save us a lot of work. Finally, in the third part, we'll ask the question, why does the formula work? Part 1, Bernoulli trials and basic calculations. Let's start with an example. Suppose we want to flip a coin 3 times. Let capital X be the number of heads in 3 flips. That's the random variable that we want to be studying. Now each flip of the coin is what is known as a Bernoulli trial. A Bernoulli trial of a fixed experiment is one that satisfies all of the following 3 conditions. First of all, there can be only 2 outcomes in any particular trial. These are termed success or failure. When we say success or failure in the context of Bernoulli trial, we're not trying to indicate that one is preferable or the other is bad. We're simply emphasizing the fact that there are only 2 outcomes, and we term these success and failure. Secondly, all of the trials must be independent. What that means is that if we run, say, 3 trials of the experiment, what happens on the first or the second trial has no influence on what happens on the third. This is like with flipping a coin. A coin has no memory. It doesn't know whether it came up heads or tails in the previous 3 tries. What will happen on the 4th trial is completely independent of what happens on any of the earlier ones. Finally, the probability of success may not change. In other words, like with a coin, if we flip the coin every single time, the probability of getting a heads is 1/2. It doesn't matter if this is the 3rd, the 19th, or the 57th time we flip the coin. The probability of a head remains the same each time. There is a formula for computing the probability of R successes out of N trials when the trials are Bernoulli trials. Here in this slide we see the formula, and we could talk for some time about why it works, but I think we'll postpone that discussion until the 3rd part of the lesson. And right now we'll start by looking at some examples to see how to use the formula. When you look at the formula, though, I do want to highlight right here this CNR. CNR is the same combination formula that you learned in basic probability. It's the number of combinations of R things taken out of N things. Alright, let's go back to our example of flipping a coin 3 times. Let's consider that those 3 Bernoulli trials and ask what is the probability of getting exactly 2 heads out of the 3 flips. Well, we're going to let capital X be the number of 3 flips. That's our random variable. And next we need to identify all the parts in the formula. N in the formula means the number of trials. R means the number of successes. P is the probability of success, and 1 minus P then is the probability of failure. There's the formula, and all we need to do now is to plug the numbers in. The probability that the number of heads will be 2 equals the number of combinations of 2 things taken out of 3 times the probability of success squared times the probability of failure to the 1st power. We plug in the numbers into our formulas, and when we run those through our calculator we find the answer is 0.375. Here's another example. Once again we want to flip a coin 3 times. This time we want to compute the probability that all 3 will be heads. Well, here's our formula. The probability that X equals R is CNR times P to the R times 1 minus P to the N minus R. Of course, it's important that we be able to recognize what each of these letters stand for. N is the number of trials, R is the number of successes, P is the probability of success, in this case of heads. We plug those values in, C33, 0.5 to the 3, 0.5 to the 0, and multiply these out. We get 0.125 or 1/8. By the way, this is one that is easy to compute without the aid of the formula. Think about this. If we flip a coin 3 times, there's 2 possible ways for the coin to land on each one of those trials. So we have 2 times 2 times 2, or 8 possible outcomes. There's only one way for all 3 flips to produce a head, so 1 divided by 8, or 0.125, is the probability of 3 heads. That's a nice confirmation. Gives us a little bit of trust that the formula works. Alright, a third example. This time we're going to flip a coin, but 4 times this time, and let's compute the probability of 3 heads. I recommend you stop the recording right now, see if you can work this on your own, and then I'll show you the answer. Alright, to work out this problem, the first thing you want to do is recall the formula. Next, you want to identify what N, P, and R would be for this particular application. N is 4 because there are 4 trials. 3 is the number of successes that we're looking for. That's the number of heads. 0.5 is the probability of a success or a head. And 1 minus 0.5 is the probability of a failure, which in this case we'd be thinking of as tails. We run these through the formula and we find out that 0.25 is the probability of 3 heads. If we were to flip 3 coins, there's a total of 4 different outcomes for the random variable x, where we count the number of heads. The number of heads could be 0, 1, 2, or 3. You might notice that we could use our formula to compute the probability of any one of the outcomes, 0, 1, 2, or 3. Here they are in this table. I just want to point out that this is an example of what we call a binomial distribution. A binomial distribution is the distribution of a random variable that reflects Bernoulli trials. So this is the binomial distribution for n equals 3 trials, and where p, the probability of success, is 0.5. The r that you see in the formula actually appears in the first column. R is 0, 1, 2, and 3, and that of course produces 4 different probabilities. Alright, let's take one more kind of example. Up till now we've always looked at a coin, and that makes the problem a little bit special in that the probability of success and failure of head and tails are the same. This time it's going to be different. Let's suppose that we drop 4 identical tacks onto a table and count the number of tacks that land with the point up. Let's find the probability distribution for this random variable. And this time we'll say that these tacks are designed in such a way that the probability that they land point up is 0.75, and the probability that they land with the point down is 0.25. Now this is going to be a little bit different from the coins. The formula is not different, but the probability of success and failure are not the same. So we'll begin to see the formula do something that we haven't seen in the past. So let's ask this question: what is the probability of, say, 1 tack landing point up and 3 of them landing point down? Well, these are still Bernoulli trials. Remember, there are 3 conditions. Each trial has to generate only one of 2 outcomes. We call them success and failure. The trials have to be independent, What happens with one trial doesn't affect what happens with any other. And finally, the probability of success doesn't change from one trial to the next. That's certainly true here with dropping the tax, so we can proceed with our formula. The probability that 3 out of 4 tacks land with a point up would be given here. The probability that x equals 3 is C43. 3/4 to the third power, 1/4 to the first power, and when we work that out with our calculator, we get about 0.421875. As a matter of fact, we could do this for any one of 0, 1, 2, 3, or 4 of the tacks landing with the point up. Here are the calculations. You can see them there in the list. And if you were to check, you'd find that the sum of all of these probabilities is once again 1. It should be that way. If we drop 4 tacks, certainly 0, 1, 2, 3, or 4 tacks will land with a point up. No 2 of these overlap, so we can use our special addition rule, and the probability that one of these things will happen is exactly 1, because that is a certain event. Well, that's the end of the first section. You're now prepared to see the second section, and in that we'll be able to go a little bit beyond the basics in our calculations, and that second section will pretty much prepare you for most of the homework problems.